We just had an awesome feedback loop in here. I'm Justin. The camera's over there, so I'm going to bounce between you guys and the camera. Thanks for coming to the kickoff for the Dash Workshop Series. We started this kind of programming off this summer with the Dash Summer Camp, where we had a 5-day intensive workshop for graduate students. We had 20 or so graduate students from across campus come in and get a really good foundation in lots of different tools. A little background on Dash, if you're not aware of it. Dash is focusing on two different things from the libraries. The first is creating opportunities for access to trainings with these tools. So things like crowdsourcing, data visualization, mapping, 3D printing, 3D design, things like that. So offering training sessions, consultations, things like that. The other side of it is breaking down barriers to people working on these tools. So creating informal communities of practice, creating opportunities to figure out who else is working on this stuff on campus so you can connect and not try to reinvent the wheel every time. So this is the first of 6 workshops that we're going to be having. If you look on our website, which is on the screen, if you can see the screen, z.umn.edu/dash. The best part of that is the rhyme. And you can see the whole schedule. If you haven't registered already, you can, but I'm guessing if you are here or watching this, you have registered. But I think that's about it. We're going to have 3 presentations today. Michael Burkowski, who's just over there off screen, is going to talk about Intro to Programming Languages. I'm going to give a brief overview of text mining, and then Alicia Hoflich-Moore is going to talk about some data mining as well as some specifics with R. The point of these workshops is not to make you a master of any one of these things, because you cannot be a master of any one of these things, even in most likely 4 years of a degree in one of these things. But this is to get you started. This is to give you an overview of the tool, some projects that people have done, and then some pathways that you can go from here, whether it be on this campus, whatever campus you're at, or online through things like lynda.com. So without further ado, I will hand it over to Michael.
How much time do I have?
About 50 minutes.
Good morning. I'm Michael Burkowski. I'm a web developer with the University Libraries for about 1.5 years of my current position. Previously to that, I spent a couple of years at CLA, and before that, a whole lot of years working for Minitex in the statewide interlibrary loan program, if you're not familiar, in a bunch of different capacities. And I'm here really to just give you an overview of, let's see if I can find my own, it's going to be different window, yeah. Let's see.
Go under window.
Oh, right, that's the one. Get that one back up. Okay, thanks. Sorry. I'd like to give you an overview today of a couple of different sort of classes or categories of programming languages that you might encounter or you might never encounter, and to know how to identify the ones that you might ever need to kind of know about. As much as we have time for, to go over a couple of concepts that are common to pretty much every area of programming. There are like 3 or 4 things that programmers do that account for almost everything that you would ever see in a computer program that you yourself would run. It's a couple of very small like nuggets of idea from which we operate pretty much everything. So what I would recommend is, if you have a screen in front of you, to follow along. I have this presentation up on my website. That's probably a little small. I wonder if I can make that a little bit bigger. Yeah, it's making it smaller. That's weird. Huh.
You have really big arrows now.
Yeah, okay, well, forget it. Anyway, my website, burkowski.net/dashcode, is where this presentation resides. And it's an HTML thing, and you can kind of just click on the little arrows down here at the corner to go different ways. And I'll be going left and right and up and down, and I'll let you know which way I'm going if it's not obvious. So let's just move in. Some things actually, I already said that. We'll look at a couple kinds of languages. I want to stop and pause for questions now and again, if you should have any. And we'll try to get through as much as we can in 50 minutes. And please let me know if I'm going too fast, or if you want more time on something, because I have easily enough content to fill like 90 minutes. So, okay, what's a programming language? It's a well-defined syntax or grammar or, well, language. But, and what does it mean to be well-defined? It means that basically everybody who needs to use it agrees on how it's structured, agrees on what the rules are. And that can be as simple as internally at one particular company or organization, a group develops and defines a language and writes down the rules, or it can even be defined like by an international standards body. And most of the ones that we would deal with on a regular basis are those that are known, well known internationally. And it's meant to be more or less human readable, not readable like prose necessarily, but something that you, if you have knowledge of that syntax, can look at and basically understand what it's doing. And the computer's job then is to take that stuff that is kind of human readable and make it into something that is extremely machine readable, into its own machine code that the CPU inside your computer knows how to make electrical instructions calculate ones and zeros out of. And that's not at all human readable. So the encompassing term for all of this is source code. We'll either call it source code or just code. Pretty much any language will use that term code. Okay, there's a couple of different types that I'd like to mention today and their main uses. The first one is compiled languages. This is sort of where programming started, where programming languages started. Compiled languages will build that executable thing like notepad.exe on your Windows machine, or minesweeper.exe in 1995. That one file that you end up running by whatever means, double click it or whatever, that launches and runs your program, and it's more or less contained inside that thing. From that thing, that minesweeper.exe, it's difficult, if not impossible, to go backward and derive what the source code originally was. You can kind of figure out what it's doing, what the machine is doing, what the computer itself is doing, but you can't really go backward to get the human readable original source out of it. We call that thing a compiler, the thing that works in between, that takes your human readable stuff and puts it into the machine's perspective. So where are these things used? Okay, I said Minesweeper. It's not a larger complex application, but compiled languages are preferred for things that are really big and things that need to be really fast and efficient and have a lot of parts that are interconnected. And they're used when you really, really don't want the source code to be known. If you're protecting like intellectual property, you don't necessarily want to make it easy to derive all of your secrets and how you built it. Most of what software you run on like your laptop in front of you, like even the operating system itself and like your word processor and your web browser, those are generally written in compiled languages because they can make them really highly, nicely optimized for the computer that it's running on so that they're faster. And that's really what we're after a lot of the time. My choice of red is not so great for where that light is. But some common examples you might have heard of. C and C++ are older-ish languages, still in very wide use today. C# down there, C with a little hashtag, you pronounce it C#, like a sharp sign in music. That's sort of the modern language of Microsoft stuff. It's basically any Microsoft product that you've used in the last 8 to 10 years is probably running C#. Java is a really widespread language that's in everything, all over the place. Business applications abound. Written in Java. Android phones, everything is in Java for the most part. Objective-C is the language of your iPhone and your iPad. Stuff that's compiled down to iOS devices is written in Objective-C. And then there's a whole bunch of other languages, words you may have heard of, Fortran, Pascal, COBOL, especially if you remember the Y2K problem now 14 years ago when they were talking about where are we going to find people who still know how to code in these languages, because the systems, the financial systems running the banks that had the potential to fail in the Y2K problem, which was a date handling thing, whether you use 2 years or 2 digits or 4 to make a year, incidentally. It was a big worry for a lot of organizations that their people just didn't know how to do that anymore. They needed to hire the people to fix these systems. And they still use those systems because they're extremely fast and they're extremely reliable, even though they're kind of arcane and overly complex nowadays. So that's the class of compiled languages. The ones that you, as people in libraries and humanities, are probably more likely to encounter sooner than those, the compiled ones, would be the interpreted languages, also known as scripting languages. The big major difference between these and the compiled languages is that you don't have to use a compiler to translate it into that single executable minesweeper.exe file. You can write the source code, and the computer knows how to take the source code that you wrote right then and there and make it do something useful. And because of that, it's also possible to take the source code that you wrote, give it to somebody else, and they can use it right then and there without having to compile it into something that their specific computer knows how to use. And so a lot of modern open source applications and web applications are written in compiled languages. Except for, again, those really big ones like banks, financial systems, PeopleSoft, Amazon.com is not running in simple scripting languages. The Alma library systems are not running in simple scripting languages. They're a little overly complicated for that. They're really, really good when you need to build things quickly. You can code something up, make a prototype, and just make change after change after change to it, and run your changes right as you do it without having to kind of stop and compile. There's an old joke for software developers. The manager, I don't know how to set up a joke, so I'm not going to bother, really. Management wonders why their people are sitting around doing what looks like nothing, and they say, I'm not doing nothing, my code is compiling. And like literally, it could take 20 minutes or half a day even to compile a big complicated application. In fact, if you remember in Jurassic Park, when the actor who was Newman on Seinfeld was the software developer at Jurassic Park, that was the reason he stayed late, that his code was still compiling. So it's a real thing.
The next KCD comic about that too.
Yeah, right. Yeah. So there's an XKCD. If you're familiar with that strip, look up the My Code's Compiling. You'll find it right away. So speed, though, the speed at which the program actually runs is less fast and sometimes a lot less fast than the compiled languages. But it's just not. It's not the need when you're working with these. You really want to use these when you need to work quickly to get stuff done. Some examples you might have heard of. Python has a really nice, easy learning curve, really readable syntax. It's used a lot in science these days. Next, underneath it, Ruby is even more readable in terms of its syntax. A lot of newish web applications, big web services within the last 5 years or so are built on Ruby as their foundation. PHP, you've maybe heard of as well. A lot of our websites here at the University Libraries run on PHP. It's really, really easy to learn. It's installed everywhere. If you went right now and got a new signed up for a new account on Bluehost or GoDaddy.com or some hosting service, without a doubt it would run PHP, and you could right then and there put some PHP code up there and it would just work right straight away, no problem. And that's the reason that it's really popular. It's not always the easiest language to use correctly, but it's popular because it's everywhere. JavaScript is the language that your browser uses to do stuff for you on the screen after you load a web page. Like if you click a button and it makes a little piece of text fly in from the side or flip over or blink, JavaScript did that. And we will come a little bit later and actually do some of this stuff if you've got a screen in front of you. And so even though everything I mentioned here is in some way tied to the web as a web language, they're all really general purpose languages in that you could build any kind of system with them. It's just that the things we tend to build with them are web things. Python is the exception there. I'm going to head to the right now. OK, markup languages are less about instructions for how to do something and more about how some output should look. And I don't say like a document, I say output because it doesn't have to be something that is for even a human to read. It could be something that is for a computer to be able to read. Librarians are pretty familiar with markup languages. Okay, so they do this a lot of the time by taking some kind of formatting descriptor, like this little span here, with some color attribute here, and wrapping it around some block of text or output in order to change how it comes out. Sometimes these also have the ability to do little bits of arithmetic, things like that, but they're not really meant for doing that kind of arithmetic or complicated like processing and changing of stuff. So some examples: HTML and CSS. Every single day you sit down at a web browser, you stare at something that came out as HTML all day long. And your web browser knows how to take that and show it to you in the way that the people who wrote the code intended it for it to look. XML is another format that kind of looks a little bit like HTML in that it has those angled brackets like that span tag I showed you a minute ago. We'll look at these in examples. But it's meant for structuring data and transporting data between systems, and it's pretty widely used. This one, third one down, is JSON or JSON, depending on who you ask. And it really is just something that came out of the JavaScript language. A very well-known developer named Douglas Crockford looked at the JavaScript specification and said, if we just took this thing that's used for defining what's called an object there and send it to another computer, we could use that as a way to send structured data. And it works really well, and it's a lot kind of leaner than XML and some other ones. Markdown is one of my favorites and becoming a lot of people's favorites. It's a really simple language that is used to write a document quickly that is then translated into more complicated HTML. So it's becoming really popular with journalists, people who are typing up instructions for things. Usually the instructions of how to do something is not too complicated a document. It'll have titles and headings and bullet points and things like that. All that stuff is really fast to type in Markdown. The last one listed down there is it looks like LaTeX. It's pronounced LaTeX, and it is a typesetting language that is used in pretty much all of academic publishing. Especially in the sciences, if you were to write a paper and have complex math and scientific notation, you can do it in that language, and then the publishing company would know how to take that and make it into that very complicated physics equation that's going to get published. Yes?
Well, this is fascinating because these are all open access
Yes.
codes.
Yes.
So what happens to those like Dreamweavers and Front Page and all those?
So the question is, these are open access, open source languages that anyone can use, and so how do things like Dreamweaver and Front Page fit into this? What Dreamweaver is not itself not a language, but it's a program that knows how to use several of these and basically make it easier for the user of Dreamweaver to make HTML code, for example, without having to hand type so much of it. It puts a simpler user interface on top of a lot of these things. And Front Page does more or less the same thing, but is not as often used nowadays as it was, say, 10 years ago. Yeah, I don't know. I don't either. I haven't heard anyone mention it in a while. So, another question?
I was just saying, it's like PHP that we were talking a while back. Isn't that the one that was kind of in the center of the news a little while back as the Heartbreak bug?
The Heartbleed. So the question is, was PHP related in any way to the Heartbleed vulnerability a couple of months ago? And the answer is no. That was part of not a programming language necessarily, but the SSL security layer that web browsers use to secure your data. So none of these specifically was responsible for that, although the code that thing was written in the C language. But it's not because of C that happened. It was because of carelessness. So, okay, so let's look at a couple of examples. HTML. Have you seen this before? Has anyone seen HTML before? Good. I see a lot of heads nodding. So you can probably look at this and kind of know what it is supposed to do, and that's the whole point. HTML wraps blocks of text in what are called tags, and tags generally have an opening one and a closing one that starts with a slash. And you can nest tags inside of other tags, and that makes things happen on screen. It works really well. It's worked really well for like a decade and a half or 2 decades now. The only thing about it is it takes a long time to type. There's a lot of extra stuff to type, and that can get, it gets a little bit tedious if you're hand editing it, which is why a lot of people use things like Dreamweaver or nowadays a content management system like the Drupal system the library uses. It makes it so you have to type less of that stuff. So this has a title, it has a paragraph, and then it has a list down there. What I didn't make is I don't think I have a slide that shows what this actually would look like, but I think you can guess what it would look like if rendered. The same thing in Markdown. This is why we like Markdown. I can type that, get the exact same output or very nearly the same output without having to go through all of the extra trouble of the open and close brackets and have some in the wrong place or miss one and then the rest of it breaks. It's really nice. It's really handy. So I would encourage you to look that up, and I think there's a link on one of the earlier slides about it. The same thing. Yes. Sorry.
What about the WYSIWYG editors that you see in some websites? Is that just another way of translating?
Yes. So the question is, what WYSIWYG editors? What you see is what you get. Editors that are on a lot of websites now, and certainly a lot of content management systems. Those are just placing an interface that's pretty familiar if you've ever used a word processor, which most everybody has, where you can kind of highlight and bold text and make headings using your mouse and keyboard without having to know the HTML tags. All that those do is let you type those things on your screen. The browser uses JavaScript to translate it into HTML, and then HTML is what gets saved somewhere else and sent back down to show you again later. Good question. So that same example in the LaTeX typesetting language is a lot more complicated. But then again, this is not for doing stuff fast. This is for doing stuff for publication quality and often extremely complicated stuff like scientific equations. Any other questions about markup languages before I go a little bit more? OK. Has anybody ever heard of SQL? I know these. OK. Oh, I'm happy. I'm so happy to hear that. Good. Very good. OK. So SQL is the structured query language. And it is the language. I say the language because it's almost the only one. It's the only one of broad universal significance that we use to put data in and get data back out of a database or data storage. And it's pretty simple, and it's meant to be really, really human readable, at least in simple cases. So I have up here what's called a query, an SQL query, or you'll hear people will often just say SQL, but it doesn't really matter what you say. And the query is select name, comma, email from attendees where course equals dash workshop and date equals today's date. And so you can probably understand what that's supposed to do in at least at some level. So, oh, you know what? I updated this slide and I didn't quite update it all the way. This is supposed to say attendees, not students. Attendees here is the table of data that we're going to get stuff out of, and name and email are columns in that table. This last part here, the where, we call this a clause. The where clause is a condition that says what we want to get. So if we had a table with a whole bunch of courses listed, and Dash Workshop was one of those, we would be filtering out everybody who's not in the Dash Workshop, and the date of that course was not today's date. It's really simple to get started, and it's capable of doing a lot of stuff. And it's really the way that every website that has any kind of data stored with it talks to and gets its information in and out. Oh, there it is. Pretty much every website you go to nowadays has a database behind it and is probably using SQL to talk. Of course, our library systems have this as well. So that's the only one I was going to mention in data manipulation languages today. But questions? Yes, Andrew.
It could be a huge question, but
Sure.
I don't answer it usually.
Okay.
So the history of this logic, like in maybe 10 sort of blips, how did humanity come to think like this? Answer quickly.
Yeah. Okay. Andrew's question is what is the history of this? How did humanity come to think about these things? I can't answer that at all right now. I'm sorry to say.
That's fine.
Yes.
Well, I mean, coding languages were a requirement as they started to develop the digital computer and needed a way, it's a long, you're asking about sort of the longer history of the development of the computer.
I don't need an answer, but
Yeah.
We'll talk, Andrew.
Yeah.
Yeah.
Cool. Thank
But
you.
yeah, like I'm taking a whole course on that right now.
Okay.
so-
Okay. Yes.
There's another question in the back.
What kind of language are screen scraping programs?
A question is, what kind of language are screen scraping programs? Okay, so what a screen scraping program does is, let's go back to the HTML example. A screen scraper is a program that is supposed to go out and get this HTML, which is intended to go to your browser and show this content on your screen, but go and retrieve that and take it to some other location. Instead of it going to your eyes and your brain, a screen scraper goes and reads it and takes maybe only some parts of it that it wants and stores them somewhere else. So a screen scraper can be written in any language. I've myself written one in the Python language, and I think I've probably written another one in PHP as well. But its job is to go and read this kind of markup and take data and store it someplace else. So. More questions. Amy, yes.
So I've never heard of Markdown before, and I'm horrified that I've been marking up tons of stuff all this time. What editor do you use? How do you?
You can use any kind of, for all of these languages, you can use any plain text editor. Plain text is the key. You don't want to do these in Microsoft Word because you'll end up with a whole bunch of extra stuff that's not just the text. So any plain text editor you can use, and then different services. A lot of different services are starting to support Markdown. Talked with David Naughton, and I think he uses a Markdown editor that as you type, it shows it looking like it's rendered output. So
Like Text Wrangler or any of the?
you could certainly type it in any of those, but there are some that will take your Markdown as you type it and make it look nice. So. RStudio? Okay. Yes. Steve.
Sorry, I came in late. You've already covered this, but I know XML has headers.
Yes.
Are you going to cover that? And is that important to using these languages?
I was not going to mention that. I would say that's a little bit out of scope. A lot of these languages have metadata that you need to have at the top in order to describe what kind of document it's going to be. And I guess I didn't have an XML example in the markup language. And if I had one, it would have definitely had a header in there. Anyway, a lot of these, actually the HTML does kind of have a, this is a very tiny fragment of an HTML header up there. And often there's a lot more stuff in there that pulls in other files from other locations, describes what kind of document it is. Most of these languages will have some type of header like that. Markdown doesn't really need it. LaTeX has a whole lot of things because that's where you store publication information, authorship, and all of that stuff gets encoded in there. Let's move ahead because I don't want to use up all of our time. Okay, you can do a lot of cool stuff with the computer that's right in front of you, and you don't even need anything that you don't already have, and that's great. You can use your web browser to manipulate web pages right out of thin air, basically. So go ahead and go to www.umn.edu, and I'll go there too, and we'll just have a kind of a look at it a little bit. It's got some basic areas laid out on it. There's a header up at the top, not the same as the metadata header, but like the top of the page, and that will kind of stick in place for as you travel around through the site. It has a big middle kind of content area. It has some sort of sub-content here. And if I scrolled down, there would be like a footer at the bottom. Pretty common layout for a web page. OK, but we can actually go and look at the markup, the HTML markup that willed it into being right now. I think last time we found out that Option U doesn't actually do this on Mac. I don't remember, but you can always right-click or whatever your equivalent of right-clicking is and view page source to see the source. So let's do that here. I think what's that? Option click, command click, control click. There we go. If I control click on this Mac and view page source, it will bring up a white screen full of HTML and also some JavaScript. But and you can scroll through this and you can see. Let's see if we can find something here that's pretty. So here's a form. Somewhere on there's like a search form, and there's a starting form tag and an ending form tag and a bunch of inputs inside it. That's what makes up the web pages that you view all the time. There's not a lot to it, really. Some server somewhere in some other location sends this block of text down to your computer. Your browser takes it and arranges it into what's intended as for it to look like. OK, but let's look a little bit into the structure of it a little bit more. Let's see. If you right-click on the big M logo at the top in the header and choose Inspect Element, if you're using like Chrome or Firefox. Did I say that was Command? Oops, no. Inspect Element. It's going to bring up a little thing called the console at the bottom. I'm going to just try and make this a little taller if I can. Where's the? There we go. This is the HTML inspector. Now, you saw the HTML source code already. That's just kind of raw text as the browser got it. This is what it looks like after the browser reads it and organizes it and figures out what's inside of what else and where things go. And so here's that banner. If I kind of move my mouse around, you'll see different things turn blue. There's that form we were looking at. I can expand that, and you'll see there's those inputs in there, the search input and the search button. This is how web developers spend a lot of their time, either looking at other people's stuff or looking at our own stuff and arranging through and testing what we've done. So there's our M logo. What were we going to do next? Let's see. Oh, there's the picture. We can change it. We can do something clever to it or not clever. Let's see, what could we do? What was I going to do? I could take one of these, like, let's see, let's highlight, scroll a little bit, find one of these links here. Here's a list of links. Here's one that says academics and research. Let's open that. And let's change it to pizza and beer. And there we go. It's as easy as that. But we haven't actually, I didn't just modify the university's website. I modified my browser as it knows it right at this moment. In fact, if I refresh the page, that'll just go, of course, go back to how it was before. So, OK, so remember, JavaScript is what your browser uses to do stuff. You can also do stuff to that screen programmatically. So let's go back to the one we have. Keep this open if you're following along. You should have a console tab in your console, and you should. Once you go in there, there will be like a little blinking cursor, and we can do stuff here. Whoops, let's go head down here. So you can do like simple arithmetic here. I can say 1, 2, 3 plus 3, 2, 1 and press return, and it will say the answer is 444. Cool. We can do more complicated things than that, though. I'm going to copy and paste this here. Paste this here and press return, and keep an eye on the top of the screen there. I just deleted part of the yellow header up there, and it caused everything else to shift up as it went along. We can do even more heinous things than that. So document, the whole thing is a document. .body, that's the main part of the content that you're going to read. .style is what it looks like. .background color is the color of the background, equals lime. And so we just totally ruined university branding, etc., by making it just a horrible lime green color. And if I just go back and, of course, refresh it, everything's back to how it's supposed to be. Let's move the console down a little here. How much time do I have? About 10 minutes? OK. All right. So great. Let's hold questions here, because I want to just get into a couple of other concept things before we run out of time. So there are a few things that programmers always have to do. And you can do these same things in one way or another in any of those languages. The only thing that really differs is not, the thing that differs isn't the concept, it's the syntax for how you say the thing, how you make the statements you need in order to make the program do what it needs to do. So, okay, the first of those concepts is statements. Most programming languages deal with statements one at a time. You say one instruction, the computer does that instruction, then it does the next instruction, then it does the next instruction, and the sequence of those things is what matters most. And so if you copy and pasted those three things there into your console, if you still got it open, you will get the output right back after you press return, enter, of course. So hello-workshop is my output. And you can see I got 3 separate discrete lines of output for each of my 3 instructions. That's really all there is to statements. Statements is a statement. It's really just a vocabulary word here. OK, things that matter more are variables. A variable is a place to hold some chunk of data for some amount of time. And it could be any kind of chunk of data. It could be like a string of letters that together make a word. It could be a number. It could be a complicated block of stuff that is related and stuck together, but it consists of more than one possible thing. So if I take all of this here, incidentally, these kind of green lines that start with 2 slashes, those are known as comments. They don't do anything, but they are like reminders in the code for the programmers to see what stuff is supposed to do and annotate it, really. I can run those things. And let's look at the output. This is JavaScript syntax. We're doing JavaScript operations here. Using this var keyword, I created a variable. This one I think I can make bigger. Yeah, that's much better. OK. I sort of willed it into existence. I made a variable, a place to store one, so the browser knows about it. I gave it a new value. The value is hello world, and that's what we call a string of text. And then I did something to it. I called this function called toUpperCase on it, which made it all uppercase. And I took the result of that, and stored it back into the original variable. So now if I type that variable again, if I just type it here, the console will show that its contents are now hello world uppercase. You can use variables like you would use them in algebra. You can add to them, subtract from them, substitute them for other things. That's the whole point of them. I'm going to run these as I go, just because I might need them again later. So now we have this one called the sum, and its value is 100. And finally, I mentioned that you could store like collections of things in them too. I'm not going to run this one. I'll skip over it. But I have a list here of states: Minnesota, Wisconsin, Iowa, North and South Dakota. And I stored them all into one variable called state list. And we can go back to that list and get at each one individually by its position in the list, its index. Okay, so next big important concept are logic and flow control. If something is true, do something. If that thing was not true, do something else instead. This is what probably 75% of all programming is thinking about those conditions. And that's what we call the something. If the something is true, that's a condition. If 1 is greater than 2, walk out that door. But 1 is not greater than 2, and it's never going to be, so no one's ever going to go out that door. Else, otherwise, stay in your chair. So here you sit. That's really all there is to it. And we can use those. Let's see. I can scroll this. In this block here, I'm reusing that variable, the sum. And if you still have it, you run it. You should see some of this do something. You can use variables in that context, just like you can print them out straight on the screen. A whole lot of programming is logic flow like this. The other whole lot of it is looping. Most programs, most of the time, just do the same thing over and over and over again, even if it doesn't seem like it. And that same thing that they're doing over and over again could be as simple as just waiting for you to move the mouse. And literally in the background, I'm not kidding at all, there's a loop going, just waiting to feel your mouse move 1 pixel over and 1 down or something. And another easy to conceptualize example is if you go to, I don't know, you load up your bank statement, and you see on your bank statement a table, and the table starts at the top at the last or most recent or whatever, however it's sorted, transaction, and lists the rest down. A loop in the background has gone out. First of all, some SQL has gone to the database and got that information for you, brought it back to the thing that's processing it, and it ran a loop that 1 by 1 printed those out to the screen. That's all there really is to it. Did anybody ever code in BASIC like in 1984? A lot of you did. Yeah. So does that look familiar? So this is I use BASIC here because it's so easy to show what's happening. BASIC has a line number. This line is numbered 10, and this one is numbered 20. They have to be sequential somehow. And the line at number 10 says print hello world, and the line at 20 says go back to 10. So there you go, forever and ever.
Yeah,
yes.
There's no end function either, is there?
Right. No. Yeah. I didn't.
Might crash a browser.
Yeah. No. This one would. This is a program that you have to hit the switch on your computer, the off switch, to stop, because it will go forever. Okay, so there's, yeah, I've got five or so minutes. Okay, there's a couple of different types of loops that are really kind of important to differentiate. And the syntax that you're looking at here is how you express these particular loops in JavaScript. This would look very different in Python or Ruby. It's just a matter of learning how to say them. So the for loop is what you use when you know how many ahead of time of something you have to do. And so in this case, this one says for a variable called I and start at 1, and until I is as long as I is less than or equal to 100, this just means add 1 to it. Whoa, what happened? What on earth was that? Okay. So we're going to do this 100 times. We're going to do something here. Let's clear. I don't know how to clear that. I'm going to paste that in and press return. And 100 of these have been printed out. So that's what you use a for loop for. And like the example of your bank statement printing out, your bank knows if you say give me only 25 at a time, a for loop is going to be the thing in the background that figures out which 25 to give you. I'm going to skip the part about the state list there because we didn't run that. But the other one is called the while loop. Do something while something else is true, while a condition is true. And that condition can be as simple as while the word true is equal to true, which means forever. Just keep doing it. And so what the while loop does is wait, is just keep doing the thing inside until the condition is not met anymore. So that's really handy for like your browser waiting for input from your mouse. It's really handy for like a question guessing game. While the answer is not the answer you expect, keep asking a new question. And in fact, we can run something kind of like this now. That's going to take, hopefully this works. Let's see if this is going to work here. We'll paste this in here. It's going to make a variable, and it's going to wait. It's going to keep doing the thing it's doing while that variable, which is called input, does not have the value of done, the string, the text, the word done. So let's see if it works. It pops up a window, and it's asking for something, and I'll type in something. Oh, no, it's not done yet, so it's going to keep asking again. And so as long as I keep not giving it the input it expects, it's going to keep producing that pop-up. So finally, it wants done, and I say OK, and it says, great, thanks for playing. The while loop, that's all there is to it. So programming is learning when to use which of these big concepts. And you'll always need to use all of them. And it's just kind of a matter of thinking through the instructions that you're going to have to give the computer and giving them in a very well-ordered and explicit way. Because if you don't do it in a well-ordered and explicit way, your program will break. Computers are really, really good at following instructions, and they're mostly terrible at filling in information that they don't already have. And so that's the job of a programmer, is to be really specific about what you need done. Let's see. OK, some places you can go to learn how to do this stuff yourself. Lynda.umn.edu, we have a site-wide license to the lynda.com service, which is a video tutorial service. And they have quite a lot of videos, and most of them are really, really good. Some of them are really long. But they're really helpful, and they start at a very basic level, and they progress in a really smooth and incremental way. So I would really recommend going there. Codecademy differs in that Codecademy actually asks you to type code. Lynda, you're just watching videos. At Codecademy, exercises are presented to you, and you can't advance to the next stage until you have figured out how to solve that exercise. It works really well. I've been through the tutorials there for 3 or 4 different languages to kind of get a feel for how the site works, and I quite like it. Have you heard of GitHub? OK, so GitHub has become almost the world's de facto open source code repository over the last couple of years, unseating some other services that predate it by a number of years. We have a university-specific github.umn.edu that is a walled garden for only our stuff. So anything you would put on public github.com is obviously public, unless you pay them money to protect it. You can put whatever you want on github.umn.edu, and all staff, faculty, students are welcome to use it. And stuff that's placed there is made private to the university, or even more private to you yourself. So all you need to go there is your university ID. And lastly is actual public GitHub. I would really kind of recommend going to github.com and just clicking around on find like the list of popular projects and see what's there and see what languages they're in, and get a feel for what those languages look like, what the syntax looks like. You don't have to understand any of it really, but you can go and read the comments, for example. The thing that made GitHub so different from previous open source code repositories is that there's a social component to it where people log in and can comment on, say this, this doesn't quite work right for me at this exact line here. I would suggest using this other line instead. And the developer can say, yo, that's a great idea. I'll take your changes and incorporate them. And all of that exists in a very public way right on the web. That's what makes it a big departure from the way things used to be done. So take a little bit of time to go to those. Any other questions? I'm kind of out of time. Yes?
I just had a question about taking code and using it.
Yes.
And I remember that you should not just go to a place and get code and take it and then use it. But then now with GitHub, it's kind of confusing, and you just really want to copy that code and use it.
Well, and so just like, what?
Repeat the question.
Oh, sorry, repeat, yes. Sorry. The question was, can you just take code and use it that you find? And more or less, that's not. And the answer is, code that is posted on a place like GitHub will usually have with it a license file. And the licenses will give you what rights you have to use it. And your rights might be, for example, to take it and do whatever you want with it, change it in any way you want, and then just give that away for free. Or your rights might be to take it and use it, but you have to include the original license with it when you redistribute it. And so there are several different software licenses that are commonly used, and people can just create their own. So there will be usually license restrictions on it of some sort. But if the code has been made public, there's a good chance that the people who have posted it want it to be public, and there's probably an open source license accompanying it.
And that there have been people who are looking at that code to make sure it works, and if it doesn't work, there's going to be people saying that. So.
Yeah, it's called the issue queue on GitHub. There will be a thing that says issues, and that's where stuff that's broke will be enumerated out by the users who found the breakages. Any other questions? Thanks. Thanks a lot for having me. This, again, you're probably already there. That's the slides, the live slides. Here's the PDF of the slides. I've also stuck it on Google Drive, but I don't know if you can even click that link. Who knows? And I developed it on GitHub. So if you want to look at the HTML source that makes these slides, it's there on GitHub, and you can browse it. My email's there if you want to contact me, and Twitter. I don't know where that went, but that's M. Burkowski is me on Twitter. So thanks again for having me, and please contact me if you have any questions.
Thank you, Mike.
Thanks.
Give that microphone. So I am going to talk to you briefly about text mining, but I'm going to start with some thoughts on data mining first. Let me just pull this up. You can follow along with this presentation. Michael's using the fancier back end where he did all the coding himself for the presentation. I'm using the more noobish front end called slides.com, which is built around the same platform. But is a little bit more user-friendly if you don't have a good background in HTML. So you can do it at this link, bit.ly/1RORBLS. So we talked about the many different websites that are using these types of languages that we visit every day. Something else that is happening every day is this process of data mining. We hear about it all the time. This is the algorithmic analysis of large data sets, aka big data, which is something you've probably heard a lot too. They're finding patterns through these different algorithms that are indiscernible by human analysis alone. You could not look through this much data to see these patterns. There is no human way. You have to spend many, many lifetimes to do that. And it's used for lots and lots of different types of data. Some for good, some for bad, depending on how you say things. Ranging from NSA metadata to Gmail reading your emails for advertising purposes to what I'll talk about in a little bit of scanning through hundreds and thousands of texts to discern patterns about all the novels published in the 19th century. So Alicia is going to talk more about the data mining piece of this. We're going to introduce you to some stuff in R, but I first wanted to talk to you about text mining. This is kind of a subset of data mining. At this point, text is just data to be run through. It's a different type of data that to be mined. You'll see this referred to in a couple different ways in the literature about it. So one is distant reading. This is Franco Moretti, who's going to be here next week, Thursday and Friday. He's a professor at Stanford. He started the Stanford Literary Lab. And he talks about different distant reading as opposed to close reading. Not opposed, but as a complement to close reading. I'm going to read this sentence really closely to get the meaning of it. Whereas for him, he wants to do distant reading, where I am going to read with an algorithm all of the novels published in the 19th century that we have, that have been scanned and can be read by a machine and by some algorithms, and looking for patterns. So one of the things he did was looked at title length changing over the 19th century and what could have caused different the overall length of titles to change over the course of the century. You also see this referred to as macro analysis, and this is by Matt Jockers, who started at Stanford and is now at, he's at, what? Nebraska, thank you. He has a book, actually, I have it right here, if you want to take a look at it. So again, he goes through this process of, the different questions you can ask with these larger patterns, these larger sets of text. Again, you cannot read all of these texts in one lifetime or 10 lifetimes. You are put at a scale that you need machines to do it, because machines are really good at reading text and seeing these patterns that we can't see. So a couple different examples. Oh, the tours, they always interrupt things. Thank you, Jenny. We saw a few examples if you looked at this website, and that was supposed to work. Well, Ted Underwood, text mining. So Ted Underwood is at Illinois, and he is a very prominent text mining scholar. And if you've read this, you can see some examples that he has done. He was working with a lot of 19th century things. So he's looking at, genre classification and categorizing documents. You can see differences in vocabulary. So if this set of books in the 19th century had these kind of vocabulary characteristics, what does that look like if we look at the 18th century texts? And again, this is all dependent on, that these being scanned, these being available, these being OCR'd, optical character recognition, and having them be accurate. And so a lot of work goes into getting these texts put together and readable in this way. You can also look at, one of my favorite features is tracing the history of a particular feature, like words or phrases over time. So you can see how to use a loaded example, man or woman changed over time, how they were used in different ways. And so you get these graphs like that. You can do this thing called topic modeling, which we'll talk a little bit about later, where you are seeing clusters of things in the text that you can't, again, a different kind of pattern than you can perceive in reading. And again, there was when in the summer camp, a student was working with this program Voyant, which I'll show you in a second. We'll run through together. She was looking at articles by the New York Times that were about the 50th anniversary of the March on Washington, and she pulled this up and she saw that the discussions and articles and the words that were in there, if she did something like this kind of analysis, XY analysis, she could see that the discussions of the memorial and the anniversary were here, and any discussions of race were over here. And that was something that she had kind of seen in her just kind of read analysis, but she saw it visually for the first time, and it kind of convinced her of that even more and gave her some more ammunition, as it were. So let's go to the other site that I have up here. You can try this for yourself. This one just came out a couple weeks ago. Ben Schmidt is a digital humanist. out at Northeastern, and he's developed this tool called Bookworm. And this one isn't working either. These were working. Ben Schmidt. So movies.benschmidt.org. This is also really fun. So what he did is he took data from Open Subtitles. And so these are open source subtitles for TV and film. There is an API for it, application programming interface, where you can connect to a website and a database and pull content from it, rather than using what Van mentioned earlier, a screen scraping tool. So he either did it through the API or he just scraped all of it and got all of the data. So this is one that I was looking at last night. So for any fans of Breaking Bad, we can look at, these are all the different shows that are in here. So let's do Breaking Bad. And we will have Walt, we'll have Jesse, and we will have Meth. So here's Walt and Jesse, and here's Meth. This show is not about meth, even though that is ostensibly what the show is about. And so you see this, and what's interesting about this program is that when you click on this, you can actually get the texts that he used for it. What are some other things you want to look at? Give me some examples. When we refresh, we have another one, Sex, Death, Money, and Woody Allen. So he was more concerned about money in his films. You know, we did, so Simpsons. Let's do that same analysis with The Simpsons. So they've been much more concerned about money from those scripts.
Hey, Justin.
Yeah.
Could you repeat the bit.ly link? Somebody's asking
Sure.
in the chat. And I've lost it, sorry.
So it is bit.ly/1RORBLS.
Thank you.
Mm-hmm. Anything else that people want to check out with this? Any movies? Let me see.
What is the list of movies it's pulling from?
So this is all, again, this is the from that Open Subtitles. So, but you can also do things just like the English language. So he has one where he worked with ought to versus need to. This is something Ben, the huge disconnect between need to and ought to. Now, when you look at something like Ngrams, which we'll look at in a second, we can see some of these similar things, but we don't know what they're running their texts on. We don't have access to that backend. Here we can look at the text for what they're using. So this is all built on the open library. It would be really hard to base a convincing argument just on this alone. But this gives you an opportunity to look at something that you may not be able to see just alone. It's that first step. So if we go, so we've talked about a little bit of examples. I want to talk about some of the tools and techniques. Was that the question, Jenny?
Yeah, I was just thinking about, how he was able to get the text from that open source. How difficult is that to do? To actually either scrape those sites or to use the API to kind of get that data.
Repeat the question.
So question was, how difficult is it to get those texts? That depends on how much the site wants to make them available. So for instance, in that blog post that Ted Underwood wrote, he said, here's a zip file of all the text I use for these analyses. have at it. Other ones, not so much. Then you need to do some more work on your end to either connect with an API, which some of which are better than others in terms of connecting to them. Things like the Metro Transit and the Nice Ride, those ones are pretty good to work with. Others are pretty gnarly. And then there's some things that may not want their content scraped, which is then getting into some really dicey territory. So it depends, not just on what you want, but what they want to give you as well. And if the website that you're looking for content from has this kind of reuse in mind. So, any other questions? Yeah, Stephen.
Given that a lot of this depends on accurate OCR, and OCR quality has improved over the years, but it started low. Is there much analysis of the quality of the underlying text and its conversion as part of these kinds of analyses?
Absolutely. I think, yeah. So, is there as much focus on the underlying quality of the OCR in this as in the text analysis? Was the question. And yes, in that blog post he talks about doing OCR cleanup right alongside the text mining examples and the text mining processes. So there is always that that aspect of this to try and make sure that, because again, especially within a scholarly context, you are basing arguments on these texts, and which is why I think Ted mentions this, and other people will say this too, that you can't rely on this because you don't know what's going on in the background. You don't know the quality of the text, and so if you really want to make an intervention or something like that, you need to know the whole process of this. So yes, absolutely, they're kind of running parallel with each other. Other questions? Okay. So a few different examples of this. One is called TEI, the Text Encoding Initiative. This is a markup language, which Michael talked about earlier. So instead of things like Bookworm, which is reading the text themselves, you are marking up this language. And again, this takes a long time. But this has been around since the 80s and much earlier too, where you are going in just like you're doing on HTML and putting verse and stanza and line, clause, and marking up text, and that the machine then can read with it. Now, again, I haven't done a lot of work with this because that is a whole another language to learn, and there are other tools out there that I think are more suited for the kind of text mining that we want to do, because you have to mark these up first. So people have seen Google Ngrams. So if you go to books.google.com/ngrams, it's a similar kind of thing. So let's see, what do we do? Industrial and craft. Search lots of books. So we can see the rise of the word industrial in whatever set Google is pulling from. This is a really good tool to show people this kind of work and what is possible with this. This is not to be trusted, I would say. There are lots of problems with it. Jimmy Carter shows up a few different times and in weird places. So, again, and because you don't have access to what's going on behind this, I wouldn't trust it. But again, just showing your friends, look at this. This is interesting. The one that they had up was Albert Einstein, Frankenstein, Hawking. We don't know if that's, these aren't, we don't know what those results mean, these percentages and things like that. So what you want to have is some more control over this. And so let's run through some things on Voyant. So what you should do is go to this website, and this is vader.lib.voyant.com. shakespeare.umn.edu:8888. And now you can enter in anything you'd like into here. If you go into the materials folder that we have, there are some texts for analysis. You could also just go to anything from Project Gutenberg. So let's take, this is the complete works of Shakespeare, downloaded last night from Project Gutenberg. There are your downloads. And so what we can do, we can get a link to the complete Shakespeare. It's just a big, we just want a big text file. Again, what Michael mentioned earlier, plain text. We don't want a Kindle or an EPUB or Microsoft Word because that's going to have a whole lot of other stuff we don't want. We can take that link, put it into Voyant, hit reveal. It's going to run through this engine. And what you're going to get is first a word cloud and the entire text here. Now, people have probably seen word clouds. This is a little different. Now, what do we notice that we're seeing ebooks? We know Shakespeare didn't write about ebooks. But because we just grabbed the link, it's going to get all of the other material associated with it. There's a whole lot of stuff about licenses and ebooks, downloads, things like that. So what we should do instead is, what I did was I took that file and I got rid of all of the other stuff. And I just have the text of it. So we go to Upload, Add, Shakespeare, and then click Reveal. It's like 5.5 megabyte text file. So what do we see here? We see lots of words that are pretty common. Those in text mining parlance, those would be called stop words. We want to get rid of those. Not every time, though. Some people look at how, personal pronouns changed over time in the works of Jane Austen. So these words that we think of as inconsequential in one analysis are highly valuable in another analysis. But for now, let's get rid of them. So we're going to go over to the stop words, and this program Voyant is completely free, open source, developed by two guys in Canada, Jeffrey Rockwell and Stefan Sinclair. I highly recommend checking this out. So now I've gotten rid of all the stop words. So looks like shall is the most used word in this corpus. So we've seen word clouds before. Usually they're pretty static. With these, they're not. So if we click on shall, we get the relative frequency of this over the course of the text. We get the keywords in context, where they are. We also get words in the entire corpus. We have the exact count of how many words are in this text. You can also look, if we compare shall with will, I'm going to type in a word here. So will is more prominent than shall, but of course this could be a character name. I don't know if will appears in Shakespeare at all. I'm looking at the English majors in the room. I was a cultural studies and music person. So again, when you start making these analyses, you have to be sure that, well, will could mean multiple things. Do I will this to someone? Do I will this to happen? I will do this. You need to be sure of, and this is where something like TEI is really handy, because you can control the inflections and these kinds of things. And so again, just as Michael talked about, there's multiple ways of doing things with these kind of analyses of different languages that have their own advantages and disadvantages. So if we do add must here, there's another one. Must doesn't happen that much. Is that an artifact of the language? Is that an artifact of, what is, so we can start asking questions of these things from this. And again, on patterns that we couldn't do, by reading all these things at one time. You can also do this from any point in the corpus reader. And these are all interactive. You can see all the words in the document, see the trends. The one thing that you can't control as much is the division of the segments. I'm not sure where these segments break. So is this going to be, so in other ones you can have, this is chapter 1, this is chapter 2, this is chapter 3, and you know that the frequency across these things is controlled, whereas here they're kind of arbitrary designations. So that is one of my critiques of Voyant. But we have this running on a server in the libraries right now. The reason for that is if you upload it to the Voyant page, it's just voyant-tools.org, they are keeping your texts that you upload to help themselves make the program better. So you have to be careful with that. If you're using private data, copywritten texts, whatever the case might be. They have a server version now available that you can download. It took me 2 minutes to set up on my own machine. It's downloading a program, making sure Java's installed, and double-clicking on it, and it opens up into the server, and then you are just running stuff on your own machine. Nothing gets sent anywhere else. So I've used this for survey results. I was working with something with OIT about mobile development survey, and rather than reading 3,000 responses, I could get a really easy sense of what words were used the most, and that was what we could generally assume was the most important thing in this survey results, in the kind of the free response survey results. Is that something, Amy? Okay. I thought I heard you want to break in. So there's a lot of different options available for this, and it's kind of text agnostic. You can also put in zip files too. If you have a large collections of texts, you can just throw in a zip file and it'll do all of them at the same time. So either uploading files or putting in links. So if I'm doing a demonstration to someone in the chemistry department, I'll pull up the Wikipedia entry for chemistry or something like that. So we have a little bit more control with this platform. We see how things are going on. We can do more with it, but we still don't quite have access to the entire back end. If you talk to Stefan and George, they probably will be really excited that you want to work on that. But that will take a much more a much greater proficiency in development than you have. And so that's when you're really trying to work on this, that's when you're going into some more command line based text mining programs like Mallet, which is a tool for topic modeling, which I mentioned earlier, and then R, which we're going to get into shortly. These are the ones where you are controlling all of the parameters of this. And you can do much more fine-grained analysis than you can do with any type of Voyant or Ngrams or anything like that. This also has a much steeper learning curve. So that's the trade-off of having that control. Just like if you've shot any video or shot any photos, going from the P setting or the automatic setting to the fully manual setting. It gives you a lot more choices and can have a lot more, let's say, consequences for bad pictures, but it's much more difficult in some ways to get a good picture. The good thing is there's lots of people who are doing this stuff with Mallet and R. There are lots of tutorials. There is a resources document in the shared folder that has a few links to some tutorials, but you have to be familiar with the command line or familiar with the R programming language to really work on this. But this is the way to do, the hundreds of thousands of texts or all of these newspapers. that were published in a certain decade or a certain century. So because this is all kind of command line based, we're not going to have time to go through an example of this. But Alicia is going to step up now and explore R a little bit with you to show you how to get some data in and also to do a little bit of the text mining as well. So any other questions about the text mining side specifically before I jump it over to her? Nope. Okay. Alicia.
So while I'm getting set up, if you haven't already on the Google Sites, if you want to follow along and try your hand at reading in some data in R, there's a data file. It's in the session 1 of the Dash workshop. It should be. Can you hear me? All right, so while you're downloading that, I'm going to talk a little bit about R, as we've heard about from Justin. So like a lot of the programming languages, and Michael talked about earlier, it's free, it's open source. It's also a flexible, powerful programming language. So R is a really nice tool because it's often grouped into the same class as other statistical packages, like if you're familiar with SPSS, Stata, SAS, JMP, things like that. But it's actually more like kind of these interactive programming languages like Python or PHP. So it's pretty extensible, it's pretty powerful. You can do all the looping and the for commands and the while commands on your data. And there's also a wide user community. So there's custom packages, which are add-ons to R that increases its functionality. That's made for just about everything you can imagine. There's more packages than I even know about. The bad, so because it is community driven and user driven, sometimes these packages may be inconsistent. So for example, if you're doing reliability analysis, there's 3 or 4 different packages that calculate a Cronbach's alpha. They all do it a little bit differently. They all give you a little bit different output. So picking through the right package or the most used package can be difficult. And they can sometimes be inconsistent or even error prone. The ugly, as Justin mentioned, it is command line coding. And so there is a bit steeper of a learning curve than these other kind of graphical user interface programs like SPSS. But it's definitely worth learning. And I've been using R for about 6-7 years. I learned it in grad school. And I still have to look things up. But you get the hang of it. R look and feel, so one of the things about R is it differs wildly whether you're using a Mac or a PC. So on a Mac, if you open up R, you have a console window, so much like on the HTML browser, that console you pulled up, the console in R acts similarly. It's what executes your functions. Bless you. And you can open a new document, and this is a code file or a syntax file. It's where you can save all your commands and execute them in an order. You can also execute them one by one. R on a Mac has some nice text editing capabilities, which means if I type a parenthesis, you see the other one came up automatically for me. And if I type a quote, I get the next one, and it's also a different color, which really helps when you have a lot of code to kind of figure out what it is. Unfortunately, if you have R on a PC, it doesn't do any of that nice stuff for you. But there is a code editor that someone mentioned earlier, and that's RStudio. So RStudio has the same functionality as R. It has like a full screen panel kind of view. And this does have text editing capabilities, and it looks more consistent across a PC and a Mac. So if you're on a PC, I would strongly encourage you to use RStudio. If you're doing any kind of R coding than the regular R. As someone mentioned earlier, also is nice because you can edit both markdown files that were mentioned earlier, as well as R has a built-in command called Sweeve that makes it really nice to interface with LaTeX documents. So if you're writing an article and you want to put in some R output or code instead of cutting and pasting a table, you can integrate R command with a Sweeve document. So it's really nice. But I'm just going to use R for now. So the first thing you want to do is to point it to the right spot. So if all of you downloaded that data file, we're going to put it on the desktop because it's the easiest place to get to from everyone's computers. And so you want to say something like a working directory. So let's see what R has as the current working directory. And so I'm just writing git wd, and then, yep, so it's on, let's see. Yep, it's the grad student data file.
And that is in the z.umn.edu/workshop materials.
Okay, that is in the dash workshop materials with the z.umn.edu link, and I don't remember exactly the words either. /dash workshop materials if you're looking. And so it's this file right here. And I'm going to go through this kind of quickly, so feel free to follow along if you can. If not, I'm going to put up code to read it in so you can do that on your own. But the first thing we're going to do is show where the working directory is. It's just git wd and the close parentheses. In R, this is what you do for a function, which differs with the other languages. And so I can run the code from the script. If I'm on a Mac, I'll do Command Enter, and that will run it in the window. If you're on a PC, it's Control R if you're in R, and Control Enter if you're in RStudio. And then we want to tell R to look for the file on the desktop. So I'm going to set my working directory because I notice it's not on my desktop, it's on the users. And I'm going to put this in quotes, and I'm going to do a tilde. And then if you're on a Mac, you want the right-leaning slash. If you're on a PC, it's the left-leaning slash. I don't know why these things differ. And just write desktop. And that should get everyone to the desktop. And you can see the nice code editing that what I have in quotes is red. And then if I do git wd again, it now shows me that I'm on the desktop. In R, the comment section is a hash tag or a hash button, the number sign. And so I tend to like to use a lot of these to kind of separate my document, and especially when I'm doing data analysis. It's good for data management. You know what your code means later. I will guarantee you your future self has no idea what your past self was thinking. So comments are love notes to your future self. So let's load in data. And so the way you do that on R, let's see where my slides went. There's a lot of different ways to load data in R. And so unlike things like SPSS or Stata, there's not one kind of file that it reads. R can read almost any kind of file. Typically, it's a comma-separated document, a CSV, or a tab or space-separated document, like a text file. And there's different commands depending on what file you have. So read.csv, read.delim, just mean any kind of delimiter. If you have an Excel file or an SPSS file, there's different packages, and you read that in, with the command library, and that will help you read in all these different kinds of files. And so we're just going to read in a CSV document. So we'll do read.csv and get the file name of this. So I'm going to put parentheses because this is a function. I'm telling it to do something. And then in quotes, we'll want to put the name of the data set. So it's 34318 underscore grad student data.rc.csv. Capitalization does matter a lot in R. The same thing capitalized is not the same thing in lowercase. And you also do need the file extension. And then I'm going to put a couple different specifications when I read in this file. So for example, if you open that CSV document, you'll see there's variable names that are on the first row. And I want to tell R to make sure it knows that those are variable names, not another case of data. So I'm going to say header equals true, which just means there's variable names, look for them. I'm also going to use something that says strip.white equals true. And this is something where if you have a space that comes before or after any kind of text, R will put that space in what it thinks that is. So that's just going to strip the extra spaces in case you entered something weird or Excel put something weird from the front and the back. And this will help you later on. And also, I'm going to say something called NA.strings. And so NA is the missing value that R expects. And so sometimes if you have just blanks in your document, or if you have 9999, which is sometimes used in SPSS, you can tell R what's your missing variable. So mine happens to be blanks. And I'm going to push this. And you'll see the console window is freaking out. And it gets to the end and it says max printed. So this is just reading it in and dumping in the console. What we really want to do is assign it to a variable so we can manipulate and look at it later. So I'm going to assign it to the creative variable called data. And I'm just going to paste this whole thing. In R, the assigner is this little left-facing arrow. You can also use the equal sign. This is supposed to be more correct because it's used and it will work in more situations. I tend to be lazy and I use the equal sign most commonly, and I've never had a problem. So we say data, and now we just get this line that said it read it, but it stored this variable. So then if we say data and run it, we get the spit out of the data again. So there's a few different things when we pull in a big data set like this to take a look at, to start exploring it. The first one is head, and this will just give us the first 6 rows of data. So we can look at this. We have all our variables. So this is from ICPSR. This is a data set, a national survey of graduate students and their satisfaction, and a bunch of different variables. I've just selected, I think, 14 variables from that data set. So program name, institution name, year enrolled, if they completed, presentations, publications, and some things about their advisor and support. So we look at the first 6 rows. We can also look at the last 6 rows. So the opposite of head is tails. So tail data gives us the last 6 rows. Another nice command is structure, STR, data. So this breaks down the data frame. So it tells us that I have 12,138 observations. I have 14 variables. And it also tells me how R is classifying each of my variables. So a factor is like a category. So it's reading program name. It knows that these are different categories. And so some people will be in the same program and they'll have that same category value. Where things like number of articles or number of book chapters are integers. They're just numbers, and R will treat them like numbers. And so this is nice to look at because sometimes R will think a variable is something when you really intend it to be something else. So for example, we could put year enrolled as a category if we wanted to look at it that way. Another nice command is the summary command. And so this basically gives you a summary of the entire data set. And what it spits out depends on what kind of variable it is. So for example, program name, it's a factor or a categorical variable. So it's going to count how many cases have that category. So we know physics is the most common program people are coming from. Harvard University has the most respondents. The years enrolled vary from 1957 to 2007. We have 74 missing cases. And we can kind of get a view of the whole data set. Now there's a lot you can do with the data set. You can look at an individual variable. So in R, if you want to reference a specific variable, say I just want to look at the institutional name, I can use that doing a $sign and then type the variable name. So here it's inst name, and that will give me a summary of all these institutions. And it will give me a wider range of things it's printing than if I just did the whole data set. So now we can see that, in fact, Minnesota is on this list with 185 participants. You can also refer to variables in regards to their position in the data frame. So R treats a data frame as something that has a certain number of rows and a certain number of columns. And if you use square brackets, you can then refer to things, either lines or columns, based on their position. And so R takes in this as rows and then columns. So if I want all the rows, and I just want, let's see, this is the second column, program name, institutional name, then I can just say I want all rows, so I'm going to leave that blank and put a comma, and I want the second column. And I should get the same output as I did with the command above. Now there's a lot you can do to explore the data set. So you can look at different sections, you can plot things, compare males and females or whatever. Any suggestions for how we should slice and dice this data, just to get some examples? Anything people would want to see? Let's do head again. Number of articles. So we can look at, let's see, we can do a histogram. So there's a nice, R has some built-in graphics in the base package, which means you don't need to load any other packages in. So if we want to look at the number of articles, we can say hist, which is a histogram, data, and we want to say n articles published. And if we do this, we can see we have a histogram, and there's some sort of outlier right here. So something's making our articles, apparently someone has a whole lot that's making everyone else look bad, like those people tend to. So we can look at the summary, or actually let's look at which have more than 50. So sometimes you'll find that there's outliers and you'll need to dive in and say, okay, who are those weirdos that have more than 50 articles out of grad school? And so we can say something which, data, n articles, pub, and you have to type it exactly or R will get mad at you. And we want to say which ones are greater than 50. And if we go back to our console, it gives us a bunch of random numbers. Well, these aren't really random. They're actually the row numbers that correspond to our people with more than 50 articles published. So if we want to actually see their data, what we can do is, because these are row numbers, we can use that little trick where we refer to data by the row and shove that function in. So let's do data. We'll do our square brackets. For what rows we want? Well, we want the rows that are returned by this. I'm going to do that. And then I want all the columns. So I'm going to put a comma and then blank. So now if I do this, I can see that subset of people, and they're in physics and astronomy. So these are the people that make all of our other grad students, like myself, who did not have 50 articles, look bad. So we can look at them. If we decide to plot, okay, let's get rid of all these people and see what the histogram looks like, we can also do that. So we can say histogram, and we'll put this in, but I'm going to change this to be less than 50. So it's going to exclude all these other people. And we'll see what that looks like. And it got mad, which of course it did, because, does anyone know why? So this happens all the time in R. And so one of the skills in R you have is troubleshooting. Well, it's because I'm trying to shove the whole data set into a histogram, which is really meant for one variable. So what I really want to do is to say, I really only want, let's see, what column? I only want the column that's the number of articles. So I'm going to refer to it by its position, but I don't like counting. So I'm going to do names, data, which is going to tell me all the row names. I can see the number of articles published is 7. So I'm going to say I only want the 7th column for the histogram. Now R's happy. And we can see most of them are under 5. Some of them are above 5 to 10, and they trail off from there. There's another, so this is the base graphing capacities, and you can add more things to the histogram function. And if you do $hist and $any function in R and to the command window, it'll pull up the help. And this is a really great feature of R. It'll tell you all the different things you can add to this function to specify, to make it look how you like. So we can change the color. There's also some different graphic options if you use different packages. So one nice package for graphics, such as a histogram, is the Lattice package. So if you haven't installed it, you can do install packages, and then in parentheses it's lattice, and it's a lowercase l in our chars, whether it's lowercase or uppercase, and you can install it. It'll take a moment. If you haven't installed packages yet, it's going to ask you for a crayon mirror site. So that's just wherever you want to, you can pick whatever location you want. I grew up in Michigan, so I'm a little biased. I tend to pick the Michigan one, but it doesn't really matter. I tend to pick whichever one's geographically closest to where I am. Okay, and then to load it, we can go to library, and then not in quotes, we say lattice, and it's loaded in. So now we can use the lattice packages version of histogram, which is histogram written outright, which is another quirk of R. If you use different packages, they have slightly different names for their functions. We'll do histogram. We want to look at this, so I'm just going to copy and paste this. And you can see it's already a lot prettier than the one I had before. The nice thing about lattice too is I can also specify grouping variables really easily in the command. So let's say I want to look whether males and females differ in the number of articles published for those people who aren't those overachievers. So how to do that is I'll just edit this code. I'm going to put the up and down symbol, and I'm going to say what grouping variable I want to use. So let's use gender. So let's do data, gender. And if I go to my plot, you can see I have a separate histogram for females and males. I can do this for any variable I want. So if I just copy and paste, let's say I want to do marital status. I can get that there too. So it's really nice to start looking at the data, to parse the data. If you didn't know, there are many widows in grad school or marriage-like relationships.
Also that if you were widowed, you become a much more prolific public.
Yeah, cause, yeah. So correlation, not causation, but it sure seems like an advantage. Yeah, so this is just a little taste of working with data in R. There's a lot more you can do. There's functionalities for making heat maps, for visualizing things in a big scale. But because we're short on time, I want to move to an example in the text mining field. So data is not the only thing, numeric data is not the only thing R can handle. And one of the nice things about R is they have a code. Here, let me just make sure I'm not skipping anything. So we talked about visualizing data. There's some subsetting functions. If you want to save out your data frame at the end, there's ways to write it, and then wherever your working directory is, that's where R is going to plop it. You can also save your workspace and load it back into R later. That saves R as it is in that time. So any variables you have loaded, they'll be loaded. Any packages you'll have loaded, they'll be loaded. I tend to discourage people from doing this because if you don't keep track of what you've done. Typically, I just write a script and I just reload the script every time. But everything I change or load is in the script. But let's move on to text mining. So a nice thing about R is there's a package called Twitter with a capital R, which is adorable, that allows R to connect with the API for Twitter. So you can actually scrape tweets from any username about any topic from your R console, which is awesome. So it involves some authentication and some finagling up front to set it up, but I just want to show you an example of what you can do. And I'll post this, and also if you follow this link, this has really good instructions on how to log into the Twitter API, how to get an access key and all these permissions you need to use it in R. I've never done anything like this before, and I was able to follow it, so it's pretty straightforward. So I'm going to load in all the packages I need. These are the ones I need for the Twitter to get the tweets and to analyze them and to authenticate. This is library TM is a really great text mining package in R that we'll use. Snowball C is used for one of the text mining functionalities. And then we'll also make a word cloud. So I'm just going to load in all these libraries right away. And then I have already done all the authenticating. I've gotten keys and private secrets from Twitter that allows it to log in myself. So I'm just going to source that code. So this is in another R script that I'm just referencing. And then there's a function called setup Twitter authentication. And I'm just going to run this. And it says using direct auth. So now I'm in. So let's download some tweets. We will download, because we're in Dash and Dash is active on Twitter, let's just download all the Dash tweets. And so I'm going to set it equal to a variable called tweets. And so here you can put any Twitter handle you want and the number of tweets. And I'm just going to set this as 1,000.
There haven't been 1,000 Dash tweets.
No, there has not. And so because there's under 1,000, we can look at what our variable looks like. There's actually been 76 tweets. And we can scroll through and see all the different tweets Dash has made. And so it's sorted as a list. You can also convert it to a data frame. So this is this TW list to DF is Twitter list to data frame. And so we'll just do that on this object. And so we can treat then this data frame as we did that other data we loaded in. So we can look at the first 6 rows with head. And so you can see the first column we have text, and this is the text of the tweets. But it also gives us some more information. So for example, it says if I favorited, I'm actually a wet blanket on Twitter, so I just look, I don't ever say anything, so these are all false. How many times it's been favorited by other people, how many times it's been retweeted by other people, and again, it is not a retweet, and I did not retweet it, so these are all false. Okay, so one thing we can do, now that we have all these tweets and all this information, is we can analyze the text of the tweets. So let's look across all the tweets and look for patterns and what's happening. And so we can use this TM package to analyze it. So the first thing we'll do, and we've already loaded the package in at the beginning, is to build a corpus. And so here it's just the function corpus. You see we have a nested function in here, vector source, and this is just because of where we're taking the tweets from. I have the data frame with a variable. That variable alone is a vector. It's just one directional. It just has a bunch of tweets. So I'm going to run this. And so this will return a corpus element, which is a special kind of element in R. So if I just type in corpus, I don't get the same information as I do when I type in a different kind of object in R. And so what you have to do instead is this inspect function to actually view the text you've input. So we do inspect corpus, and now we see what we saw before when we just had it as a list or as a text variable. We have all our tweets. And it saves it as, get to the top, so it saves it as separate text documents. And so this is just how you would go about analyzing Twitter. If you wanted to analyze different texts, different interviews, you could load them in the same way as separate documents and look at what happens across these documents.
And where did these texts live
when I bring them in?
Yeah.
So in R, when you use them, it keeps a local in-memory copy. I'm just scraping it from Twitter, so I don't save the data anywhere, but it is locally loaded on R. So when I close R, it goes away, and I re-scrape it from Twitter. So this can be problematic if you want to analyze, say, hundreds of thousands of tweets, because it could bog down your computer a lot. If you're really fancy, there's ways around this. So for example, R has functionality to connect with Hadoop and other kinds of big data analysis things, so you don't have to be using and loading everything into memory. I've worked with fairly large data sets and it's been okay. Functions just run slower. But for the Twitter thing, I'm not storing a local copy. I could, of course, write it out and then store it. So let's do all these things that we might do to prepare text for analysis. So let's convert everything to lowercase because we have a mix of capitalization and lowercase. So I'm just going to say TM map is a way to apply functions to a corpus of data in the TM package. So I'm going to say to lower, so we're going to make it all lowercase. If I do inspect corpus again, now they're all lowercase. I can do the same thing with remove punctuation. Again, automatically it's gone. Remove numbers, which may come up in tweets. And another thing that's important to do if you're looking at tweets or any kind of internet data is to remove URLs. And so there's a function you can write in R. It's pretty easy to write your own functions. I just set it equal to a variable. I say it's a function. And then inside the curly brackets, I just say what I want it to do. So when I put something in here, it's going to do this. And so I'm just going to substitute the HTTP and then anything that's alphanumeric after it with nothing. So if I make this function and then I plop this function into my TM map because I want to apply it to my data, my text data, I can do that. And then if I look, all the weird HTTP things are gone. So this will help. Like the other text analysis tools, you'll want to remove stop words. So these really common words, and you may not always want to, but in this case we're just going to go ahead and remove it. TM comes with stop words that's in its memory, and so you can look at them by saying stop words English, and these are the list of words it has. If you're using Twitter, there's probably other kinds of commonly used words that you don't want in there. So for example, via or available are often things people will tweet that's not really content that we're interested in. So we're going to add to stop words the words via and available with this function. So then if I say my stop words, you can see it's all the stop words before, but I've added these two, so it'll remove them. And of course, you'll notice there's apostrophes in here. We've already removed punctuation from the tweet, so we'll probably want to remove it from here so they actually find the right words. And so we'll do that, and now they're gone. And so then you can do something called remove words. What words do you want to remove from your corpus? I want to remove my stop words. And so we can run this function. And then if we inspect corpus again, I've named it no stop words, so it's a new data set. You can see all these words are gone. Okay. Another thing you can do with this package is to stem words. So if you're using things like going, talking, and also talk or talked, talk is really what you're interested in. You just want to get rid of all the things at the end. You can do that easily with this, the function stem document. So I'm going to do that here. All right, so now we have, let's do inspect corpus.s. Okay, so we've done everything we need to, and let's quickly analyze it. So one of the things you can do is create a term document matrix. So we have 76 documents or tweets, and we want to know for all the terms across all of these, which documents do the terms appear? And so which terms appear in similar documents, which terms don't appear in very many documents. So we can make something called a term document matrix for this and inspect it, and it looks like this. So we have, it's very large, all the documents at the top and all the terms. And so we have a matrix of when it appears, it's a 1, when it doesn't appear. So across doesn't appear in any of these first 25 tweets. That's all this is saying. So using this, R can then perform nice functions like finding the frequent terms. So if I want to find terms that have occurred at least 5 times, I can do that. And it will turn these are the terms that have occurred. I can make it into a data frame and plot these frequent words. So I'm going to use bar plot. And now I have a plot of these words. And I can see by count. So event was the most common word, followed by digit. So digital, I'm guessing, is what it stemmed to. And dash. And then I can also find associations. So if I want to know, whenever we tweeted the word data, what other words were commonly used around it? And so you can look at find associations. And so these are almost like correlations. They're actually a phi coefficient, if you want to be technical. But so if data occurred, Tel and Zolo was most likely to occur.
It's Ellen Palazzolo.
Oh, okay. Okay, and this speaker. So these are the things that most likely co-occurred around data. And so you can get a sense of what words are happening or occurring together. And so you can also look, if you want to see what documents they appear in together, you can also do the inspect with data and tell, and then you get the term document matrix just for those two terms. Okay, so fun things we can do are create a word cloud. So we'll just save this as a matrix and sort it so that it's the most frequent to the least frequent. And then this word cloud function is in that word cloud library, and we can run it here, and we get something beautiful like this. In R, because you're at the low level, you can fiddle with things all you like. We can change the random order to be true. So right now I have random order, and the big words appear in the center, and the less frequent words appear on the edges. I can change that completely, rerun it, and now it's a random order, so every time I run it, they appear somewhere else. I can also make it a random color, so the color doesn't map onto how frequent they are, but I can change it. And so now the big words are the same color, and all the words that are the same color are the same frequencies. I can change the colors to be whatever I want. Whoops, that's not a real one. So you have a lot more control over how you want it to display. And then finally, we can do things like a cluster analysis of terms. So if we want to look across and see if we were to parse out terms based on their frequency of co-occurrence and kind of map it out and group it together, kind of like the pictures that Justin was showing, we can do that in R pretty simply. So first we want to remove the sparse terms, or else we're going to have an overloaded picture with terms that occur only once. So let's do that. And then finally, we can do a cluster analysis, and could look something like this. So now I've analyzed the data, and I've divided them based on how frequently they co-occur together. So we have, remember, digit was our highest frequency word, and it's kind of hanging out on its own in terms of frequency. And then we have dash event today, are words that tend to co-occur together over tweets, promotion events perhaps, dash camp and data, human code, critic study, student come, converse, things about when we're meeting, and check open UMN library, maybe resources. So you can kind of get a sense of the latent variables that are underlying the words that co-occur in these tweets. And so it's really nice, and I'll post this code on the Google site, so you'll be able to get access to that. Again, you will need to authenticate with the API before any of this will work, but you should just be able to run the code as is once you've authenticated with your own stuff. Are there any questions? I know I kind of flew through this all. Yes, Stephen?
Is versioning an issue with the code?
Yes and no. So R goes through a few different versions, and I've run into trouble with some of the older packages. So typically within a package, there's not a lot that breaks, but sometimes, for example, the package you used to use to do multi-level modeling was LMER, and now it's LME. And so the syntax is different, the functionality is different. Sometimes if you don't have the most up-to-date version of a package that's custom, like this Twitter package, it doesn't always authenticate correctly depending on if you're on a Mac or a PC. So there's little differences there. The biggest versioning issue I ran into was when I switched to Mavericks on the Mac, and it hid the library from itself, which was really fun. But in general, I haven't had too much. It's a good idea to put the version number in your code, so things like GitHub, they'll have what version they ran in it. I haven't encountered too much of an issue, but it's always something to consider. Yeah, that's a really good question. Yeah, again.
Sign up so that it always downloads the latest version, or do you actually go out and get the newest version every time you want to use them?
Are you talking about the Twitter data, or are you talking about R itself?
No, packages in R.
Packages in R, yep. So I have downloaded them, and then there's a place where you can go and update them. I typically just use the one I've downloaded. And if I find something's breaking, sometimes I'll go online and there'll be an update. But you can do that with packages and data. package manager. It will come up with all the different packages you have, and you can refresh the list. You can go and, if you do package installer, update all. And so there's ways to make sure you're most recent, but it doesn't do it automatically. Other questions? All right, and
Cool.
I think we're a minute
Yeah.
over, so
We're at time, so
thank you.
thanks everybody for coming today and for everyone watching at home. Next week is over it's same time, same bat time, 9 o'clock to 11 o'clock a.m. It's going to be over in Humphrey 50B. We're trying to do West Bank, East Bank, back and forth. Sorry, St. Paul. But it'll be about crowdsourcing. So I'll be talking about some projects that you can use. We'll go through some exercises if you want to develop your own crowdsourcing project. And we're going to have Anika Mo, who is a postdoc in CBS, to talk about how she uses it in the classroom, the Snapshot Serengeti project.